So you may be sitting at home watching this video, and I am somewhere else, presumably still at school, because teachers, I guess, just live at school. So if I were to guess where you are, I would say that it is very likely that I would find you somewhere in your house. So if I put X's in this house of places where you could be, so you could be in the house, maybe you have 2 stories to your house, and you're upstairs. And this house might have an attic, so maybe you're in the attic. You're likely in that attic. Where else could you be? Well, maybe you're watching this video on a phone or some kind of other device. So it's also probable that you are outside. And we'll assume any other type of thing, like a coffee shop or bookstore or somewhere else where you are, a friend's house, is included in this outside area. Now, where is it impossible to find you? Well, I know that you are probably not hovering above your house. You are also probably not in the International Space Station. So, what does this have to do with the electron and the Bohr model? Well, I can tell you, you are probably in this area. I can say you are also likely to be out here. Maybe not quite as likely, but it's possible. And I can say for sure, 100% sure, that you are not hovering above your house in the sky and not on the International Space Station. So I have a good idea, a good probability of knowing where you are, but I don't know exactly where you are. I can just say you may be somewhere. Well, it turns out electrons behave exactly the same way. And it turns out that, remember how light can behave just as a wave and as a particle? Matter can also behave like a particle and as a wave. And things that are really, really small, such as an electron, can behave as both. So it turns out that electrons can behave like a particle and like a wave. And because they're so small, we also have an important principle called the Heisenberg uncertainty principle. And what this says is that you cannot know both the position and velocity / direction of motion of a particle with 100% certainty. So what does this mean? Well, it means if I'm trying to figure out where an electron is, as soon as I know that the electron is, let's say, here, I have no idea where it was going or how fast it was moving. On the other hand, if I know my electron is moving this way, I actually have no idea where the electron is. Maybe it's here, maybe it's here, maybe it's here, maybe it's here. I can't guarantee where it is. And this is a really weird concept, because usually if we're dealing maybe with a car, you know where the car is and you know how fast it's going. But when we start dealing with really, really small things such as the electron, this becomes a problem. So because of this discovery that electrons can also behave as waves, we have to change our model of the atom a little bit from the Bohr model. Everything from the Bohr model still must be true, but now we have to change it a little bit so our electrons act as waves that we don't quite know where they are. And the answer to this came in the form of the Schrödinger model. And in this model, we only know where it is probable to find an electron in a given energy level. So the idea of energy levels are still here, except now we only know where it is probable to find an electron and not where it is guaranteed to find an electron. The areas in which it is likely to find an electron are called orbitals. So an orbital are areas where electrons are likely to be found. So below I've put an image of what is known as an s orbital. As you can see, it's made of lots of little dots. So whenever an electron can be found in an area, a dot is placed. And as you can see, the electron is usually found in this area, where it's darker because there are much more dots. As we move towards the outside, there's fewer and fewer dots. It becomes less likely to find the electron. And then finally, out here where there are no dots, it is impossible to find the electron. So the electron cannot be in this area. Let's look at a different diagram. In this diagram, I'm showing what is known as a p orbital. So this is a p orbital, and this is known as an s orbital. And this one is clearly labeled. It shows you that in this direction here, where you have these green areas, it is very likely to find the electron. Where there is no green, where it is white right here, it is very unlikely or even impossible to find the electron. So just like in the Bohr model, where we knew where we could find an electron and where it was impossible to find the electron, remember the electron cannot be in between energy levels, same thing with orbitals. We know that the electron can be and probably is somewhere in here. Every time we look for the electron, it could be here, 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 here. We have no idea where, but we know it's somewhere in this general area, just like we knew you're somewhere in your house or around your house. And it's impossible we would never find the electron here. This blue dot in the middle is just indicating the nucleus. You're never going to find that electron actually in the nucleus. And because now we're talking about the probability densities, the likelihood of finding an electron in a given area for an atom, let's look at some images of other types of orbitals, because there are actually 4 different types. So the image on the left here shows what the orbitals look like that are found using this calculation. So if you ever have a free moment and want to do some calculus, feel free to try to calculate these for yourself. So up here are some s orbitals, and if you look here where it is very bright, that tells you it's very likely to find the electron, and where it's dark, or it's black, tells you where it is impossible to find the electron. What's really neat with these is we can see that we actually have rings, so we can find the electron in the middle, and we can find the electron in this ring around it, but there's a small area in the middle there in which you cannot find the electron. It is actually impossible to find the electron in that middle area, even though sometimes we'll find it in the middle, sometimes we'll find it out here. It'll actually cross back and forth without ever appearing in this middle section. These are p orbitals. We can see they have the kind of this figure 8 shape. And then over here we have the d orbitals, and then we have the f orbitals. Just for another view of these orbitals, we have this picture. So this is a little more of a cartoony kind of diagram, but you can see the overall shapes a little bit better. We have the s orbital, which looks like a sphere, the p orbitals, the d orbitals, and the f orbitals. My favorite is this d orbital, also known as the dz orbital, because it looks like a figure 8 with a donut around the middle.